A very good morning to one and all. Welcome to the session of Engineering Drawing, Orthographic Projection of Lines, second part. In the last class, we have discussed the two orthographic projections of lines for two positions. One is when the line is parallel to VP and perpendicular to HP, and also when the line is parallel to HP and perpendicular to VP. Now let us see the other positions of the line, and before going to know about the other positions of the line, first let us once again recapitulate what we have discussed in the last class. In the last class, we have considered the position of the line as always. Now once again, always we have to consider the first angle projection. That means we will come across the terms above HP and in front of VP. Now if the line's position is like this, we can say that line is parallel to VP and perpendicular to HP. This page of the book refers vertical plane and this page of the book refers a horizontal plane, and the line which divides these two planes is nothing but the mid portion reference line, which is represented by generally XY. Now if the position of line is like this, we can say that the line is parallel to VP and perpendicular to HP. We know that whenever the line parallel to VP and perpendicular to HP, true length or true shape of the line can be seen from front view. That means on vertical plane. On vertical plane, if you project a light on this line from the front view, the shadow of the pen will falls on, or the line falls on the vertical plane, which is at a distance of some mm above this HP. If this line is mm above the HP, the shadow of the line falls on this vertical plane with the same distance from the XY line, mm distance from the XY line. Always in the front view, we have to represent the points with dash. That means if this line is assumed to be A, B, two endpoints of the line is assumed to be A and B, we have to represent it as A dash, B dash. And from top view, if you put some light from the top view, you can see this line in the form of a point on the horizontal plane. That means here the topmost point can be seen, this bottommost point cannot be seen. Therefore, this topmost point must be represented with the same letter, and in brackets you have to represent the bottom point. That means if it is AB, we have to represent as A suffix, A of B, A of B. This point can be seen certain x mm in front of VP, certain mm in front of VP. That means whatever the distance in front of VP it is, the same distance one will be there from the reference line XY. And we have considered the second position also. Whenever the line parallel to HP and perpendicular to VP, this is the position. Whenever the line parallel to HP and perpendicular to VP, the true shape of the line can be seen from which view? Top view. We have to represent it as AB. From top view, you can see that line in such a way that one of the endpoints of the line is certain distance from the reference line or from VP. And from front view, you can see only this point. The back point cannot be seen. Therefore, you have to represent it as, suppose if this point is A and this point is B, you have to represent in the front view as A dash of B dash. A dash of B dash. This point can be seen certain distance from the horizontal plane. Whatever the distance is there from the horizontal plane, the same distance will be there for its position from the XY line. From the XY line. Now let us see the third position of the line. Whenever the line is assumed to be parallel to both the planes. Whenever the line is assumed to be parallel to both the planes. That means the same line is will be parallel to HP and also it will be parallel to VP. That means its position will be like this. Line is parallel to both the planes. It is parallel to HP and also it is parallel to VP. Now, if it is the case, the true shape of the line can be seen from either of the view, either from front view or also from the top view. The true length of the line can be seen from either of the view, either from front view or from the top view. That means generally, as I told you earlier, that always we have to start from the view from where you can see the true shape of the line. As in this case, the true shape of the line can be seen from either of the view, both from the front view and also from the top view. Therefore, in such cases, in this case, you can start from any of the view, either from front view or also from the top view. Here, certain line is assumed to be at a distance certain mm above HP and in front of VP. From top view, you can see this line on the horizontal plane at a distance some xmm in front of VP. That means whatever the distance is there from the VP, its projection will also be at the same distance from this reference line. That means from top view, you can see the line AB. You can see the line AB at a distance, at certain distance in front of VP. And from front view, you can see the same line at certain distance above the HP, which is represented as A dash B dash. That means here the line comes parallel to this reference line in both front view and top view. You have to draw the line parallel to this XY line. This line appears parallel to this XY line both in case of front view and top view. Now, with reference to a question, let us see how to draw the projection of line whenever the line is parallel to both the planes, and afterwards we look over the other position whenever the line inclined to one plane and parallel to the other plane. A line AB of length 50 mm is parallel to both HP and VP. The line is 20 mm above HP and 30 mm in front of VP. Draw the projections. That means here in the question, the line is named as AB and its length is given as 50 mm, and it is clearly stated that it is parallel to both HP and VP. And the line is given at a height of 20 mm above HP and 30 mm in front of VP. Now let us see how to draw the such type of questions. Now generally, as you assume, now instead of lines I am representing the planes directly, the planes itself. This is the horizontal plane and this is the vertical plane, and the line which divides this horizontal and vertical plane is XY line. Now here in the question it is given that the line is inclined to both the planes. The line is parallel to both the planes. That means let us assume this is what the given question is. Line is parallel to both the planes. Line is given that it is parallel to both the planes and the line is named as AB. The line is named as AB and it is given that the line is 20 mm above HP and 30 mm in front of VP. It is given that it is 20 mm above HP. That means from horizontal plane it is at a distance of 20 mm, and from the vertical plane it is at a distance of 30 mm. This is what given in the question. Whenever as we discussed just now, whenever the line is parallel to both the planes, the true length of the line can be seen from both front view and top view parallel to this XY line. Parallel to this XY line. That means the true length of the line can be seen from both front view and top view parallel to this XY line. And from front view we will represent the same line as A dash B dash, and in the top view we will represent the same line as AB. That means from top view, you can see this line at a distance 30 mm in front of VP, and from the front view, you can see the same line at a distance 20 mm above HP. This is what the rough sketch for your analysis. Now let us draw the projection. Whenever you tilt the horizontal plane in clockwise direction up to 90 degrees, this VP remains at the top itself and HP comes below the reference line XY. Below the reference line XY. Now this line, projection of this line AB in the front view appears parallel to this XY line at a height of 20 mm above HP. At a height of 20 mm above HP. I have represented it as A dash B dash. At a height of 20 mm above HP. And at a distance of 30 mm in front of VP, in top view, you can see the same line. You can see the same line which is represented with the same letters A and B. And that means afterwards you have to give the dimensioning. Line is 20 mm above HP. 30 mm in front of VP. In front of VP. This is what the projection is. That means whenever the line parallel to both the planes, true length of the line can be seen from both the views, from front view and also from the top view. That means generally we have to start from the view from where you can see the true shape. As the line is assumed to be parallel to both the planes, the true length of the line can be seen from both front view and top view. In such cases, you can start from any of the view. You can start from front view or top view, because in both front and top views, the true length of the line can be seen, which is given as 50 mm, and you can dimension in any one of the view. Either in front view, you can also dimension in front view, which is represented as A dash B dash, and also you can also dimension in top view, which is represented as AB. You can dimension anywhere, because the true length of the line can be seen from any view, either from front view or top view. Here the black color lines represents thick lines and remaining lines must be thin. Here presentation of lines is very important. Whatever the output is asked to draw in the question must be thick, and whatever the helping lines we are using to draw the output must be thin. Now let us see the second one. In the second question, as you go through the question, a line AB of length 50 mm is resting on HP and parallel to VP. You have to underline the term. It is resting on HP and parallel to VP and 30 mm away from VP. Draw the projection. That means here in the last question, it is clearly mentioned that the line is parallel to both the planes, but here in this question you didn't come across the term parallel to both HP and VP. But if you read the question twice or thrice, you can understand the position. First of all, drawing itself the imagination. Engineering drawing itself the imagination. That means let us see what is the possibilities for it. Here in the question, the line length is given as 50 mm. First, let us take down the vertical plane and horizontal plane. This is HP and this is VP. And we know that the line which divides HP and VP is XY line. Here in the question, what is given in the question? The line is resting on HP and parallel to VP. Let us see the possibilities. If the line here, here it is clearly given that the entire line is resting on HP. entire line is resting on HP. That means if you assume the line as like this, here in this case also line is resting on HP itself, but it is perpendicular to VP. But according to the question, it is given that line is resting on HP and it should be parallel to VP. That means this position is wrong. What we have drawn, this position is wrong. That means if you assume this position, now here in this case the line is resting on HP. The line is resting on HP and also it is parallel to VP. That means according to the question, this position is suitable for us according to the given question. That means the entire line is resting on HP and parallel to VP, and this line is at what distance from VP? It is at a distance of 20 mm from VP. It is at a distance of 30 mm from VP. It is at a distance of 30 mm from VP. Now, whenever you see from the top view, the true length of the line can be seen at on the same position as it is resting on HP. Its true length is seen at the same position, which is represented as AB. But whereas from front view, the true length, you can see the true length even from the front view also. The true length of the line in the front view can be seen on reference line, because it is resting on HP. Therefore, you have to represent it as A dash and B dash. As we know that as usually we will tilt the horizontal plane in clockwise direction up to 90 degrees. The final output will be like this. VP comes above the reference line, HP comes below the reference line, and the point A dash B dash is lying on the reference line itself, and the projection, the top view projection AB is at a distance of 30 mm. At a distance of 30 mm. You can notice the point. Here always you should not forget to give the dimensioning. The dimensioning will be having marks in your examination. If you fail to give dimensioning, unnecessarily you will lose the marks. Now let us see the third question. A line AB of length 50 mm is resting on VP and parallel to HP and 20 mm above HP. Draw the projections. Here in the third question also, directly it is not represented that the line is parallel to both the planes. But here in this case, it is given that the line is parallel to HP and resting on HP and 20 mm above the HP. That means here in the previous case, line is assumed to be resting on HP, but whereas here in this case, line is assumed to be resting on VP and parallel to HP. Now let us see the possibilities according to the given question. At first, we have to consider the vertical plane and horizontal plane. As we know that the line which divides VP and HP is XY. Here it is given that length, the line is named as AB, which is of 50 mm length, and it is given that it is resting on VP. That means the entire line is resting on VP. Suppose if you consider the entire line resting on VP like this, it is resting on VP. The first part of the question is satisfied, but it is perpendicular to HP. HP. But according to the question, it is given that it is resting on VP and parallel to HP. It is resting on VP and parallel to HP. That means this case is wrong. This case is wrong. That means let us see one more case. Suppose if you assume the line like this. Now here also the line is resting on VP but it is parallel to HP. If it is parallel to HP, certainly that will be parallel to the reference line XY. That means here this case also it is parallel to both HP and VP itself. Sometimes the question may be asked like this also. Now from front view, if you see the line from the front view, the true shape appears on the vertical plane, which will be represented as or the same position itself, A dash B dash. But whereas from the top view you can see this line on the reference line XY, because as this is resting on HP from top, as this is resting on VP, from top view you can see this line on reference line. If inference distance is given from top view, you can see this line on HP. Here inference distance is not given. It is clearly stated that it is resting on VP. Whenever it is resting on VP from top view, you can see the true shape on the reference line, which is represented as AB. Here above HP is given as 20 mm. That means the line A dash B dash appears 20 mm above the reference line and the projection AB appear on the reference line. And the same procedure we follow in the orthographic projection. What we have to do? We have to tilt the horizontal plane up to 90 degrees. Therefore, the final output will be VP comes above the reference line, HP comes below the reference line, and the line A dash B dash appears on VP, which is at a height of 20 mm from the reference line. And the line AB appears on the XY line itself. Now give the dimensioning. Your line length is given as 50 mm. Now you should not forget to give the dimension. That means whenever the line is parallel to both the planes, one thing is clear that whenever the line is parallel to both the planes, both from front and top view you can notice the true shape. Both from front and top view you can notice the true shape. Now we have seen, up to now we have seen the three positions of the line. Whenever the line parallel to VP and perpendicular to HP, and the line parallel to HP and perpendicular to VP, and the line is assumed to be parallel to both the planes. Now just we have proceeded for somewhat just a little bit, you can see some complication in their positions. That means whenever the line inclined to one plane and parallel to the other plane, whenever the line inclined to one plane and parallel to the other plane. As we know that whenever the line parallel to VP and perpendicular to HP, true length of the line can be seen from front view, whereas from top view you can see the point. Whenever the line parallel to HP and perpendicular to VP, the true length of the line can be seen from top view, whereas from front view you can see the point only. And whenever the line parallel to both the planes, the true length of the line can be seen from either of the view, either from front view or top view. These are the positions that we have seen till now. Now, whenever the line inclined to one plane and parallel to the other plane, true length of the line cannot be seen in one view. That means in one view you can see the reduced size of the line, whereas in the other view you can see the true length of the line. In one view you can see the reduced length, and in the other view you can see the true length of the line. Suppose, let me place this position of the line like this. Now you can say that the line is neither perpendicular to HP. The line is neither perpendicular to HP nor parallel to HP. What is the position of the line now? With reference to this horizontal plane, it is making some angle of inclination. That means this line is inclined to HP and parallel to VP. This line is inclined to HP and parallel to VP. This is what its position. You can see that if you draw a line, horizontal line, you can see this inclination. This line is inclined to HP and parallel to VP. The line is inclined to HP and parallel to VP. I hope everybody is getting understood, and if not, please rewind and understand the concept. Try to understand the concept. Once you get understood these concepts, everything will be easy. Engineering drawing becomes very easy for everyone. Whenever the line inclined to HP and parallel to VP, true length of the line can be seen from which view? From the front view. That means from front view, the view where you are looking to the screen is nothing but the front view. From front view, you can notice that true length of the line which is inclined to HP. Whatever there is inclination with HP is there, the same inclination will be there for the reference line XY. Whatever there is inclination for the HP, the same inclination will be there for its projection with reference to this XY line. With reference to this XY line. Here you can see even the shadow also. Whenever the line inclined to HP, whenever the line inclined to HP and parallel to VP, true length of the line can be seen from which view? From front view. Whereas from top view, the same line can be seen. That means you can see both the points A and also the point B, but in the form of reduced length. In the form of reduced length. That means one thing should be kept in your mind, that whenever line inclined to HP and parallel to VP, true length of the line and true inclination can be seen from front view. That means on vertical plane. That means always the horizontal plane inclinations can be seen on vertical plane from front view, and vertical plane inclination can be seen on horizontal plane from top view. That all, as we know that the front views can be seen from on vertical plane and top views can be seen on horizontal plane. Or whenever the line inclined to HP, the true length of the line can be seen from front view along with its true inclination. And whereas from top view, you can see both the points, but you can see the reduced shape of the line. That means whenever you put the torchlight from the top, you can see the line. You can see a line in the form of a horizontal line with its reduced size. With its reduced size. Now let us say one more condition. Whenever the line inclined to VP, if it is like this, we can say that the line is perpendicular to VP, parallel to HP. Not like this. Now, if it is like this, the line is inclined to VP and parallel to HP. Line is inclined to VP and parallel to HP. That means whenever the line inclined to VP and parallel to HP, true length along with its true inclination can be seen from which view? From top view. That means on which plane? Horizontal plane. That means whatever it is making inclination with VP, the same for its projection also, the same inclination can be seen. For its projection also, the same inclination will be there, which can be seen from top view. That means on horizontal plane. Whereas from front view, that means the view you look on the screen is the front view. From front view, you can notice these 2 points also, but in the form of a reduced line. That means it is clear that whenever the line inclined to one plane and parallel to the other plane, true length of the line can be seen from only one view. If the line is inclined to HP and parallel to VP, true length of the line can be seen from front view, and whereas from top view you can see the reduced shape of the line. Whenever the line inclined to VP and parallel to HP, true length of the line can be seen from top view, and whereas from front view you can see the reduced shape of the line. Now, so as to draw these projections for our convenience, it is better we can draw this projection directly, but for our convenience generally it is better to rotate the view. That means let us start from the fake view, assuming that if the question is given like this, if the line is inclined to HP and parallel to VP, in the first case we have to assume that line should be parallel to both the planes. Line is assumed to be parallel to both the planes. As we know that whenever the line is parallel to both the planes, from both front and top views you can notice the true length of the line. Front view, from front view and top view. That means first of all we have to start from the fake view. As this is fake view, we have to represent with thin lines. That means actually in the question it is not given that line is parallel to both the planes, but it is given that line is parallel to one plane and inclined to other plane. In such cases, we have to start from the fake view, assuming that line is parallel to both the planes. As we know that if the line is parallel to both the planes, the true length of the line can be seen from both the views, front view and top views. And after that, we have to rotate the same line. If in the question it is given that line is inclined to HP and parallel to VP. If suppose in the question if it is given that line is inclined to HP and parallel to VP, as we know that always HP inclination can be seen from which view? From front view. That means on which plane? Vertical plane. Therefore, in the front view, you have to rotate this fake view up to the given inclination. You have to rotate this view up to the given inclination, and if you project the same to the top view, you can see the reduced shape of the line. You can see the reduced shape of the line. Suppose if the inclination with VP is given and parallel to HP is given in the question, in the first case is common, we have to start from the fake view, assuming that line parallel to both the planes. As we know that if the line is parallel to both the planes, the true shape of the line can be seen from either of the view, either from front view or top view. This is the fake view. But actually in the question, parallel to both the planes is not given. Line is inclined to VP and parallel to HP is given. As we know that if the line is inclined to VP, always VP inclination can be seen from which view? Top view. Always VP inclination can be seen from top view. That means on which plane? On horizontal plane. That means the line works. That means we have to tilt this line in making inclination with VP. That means from top, in the top view, you have to rotate the fake view which you had drawn previously. You have to rotate the fake view up to the given angle in the question, and if you project the same to the front view, you can get the reduced length. Now just keep it in your mind. I will explain you how to draw the line whenever it is inclined to both the whenever it is inclined to one plane and parallel to the other plane practically. The thing which you have to keep in your mind is if the line is inclined to HP and parallel to VP, always HP inclination can be seen from front view. That means on vertical plane. If the line is inclined to VP and parallel to HP, always the vertical plane inclination can be seen from top view. That means on horizontal plane. That means if inclined to HP is given, simply you can remember this. If inclined to HP is given, always HP inclination should be drawn on vertical plane. That means in front view. Whenever the horizontal plane inclination is given, always horizontal plane inclination must be represented in top view. That means whenever the horizontal plane inclination is given, that should be represented in front view. That means on VP. Whenever vertical plane inclination is given, that should be represented in top view, that means on HP. That means HP inclination can be seen in on VP. VP inclination can be seen on HP. Now let us, with reference to the question, let us see how to draw the projection of a line whenever it is inclined to one plane and parallel to the other plane. Thank you. Now let us see the projection of line whenever it is inclined to one plane and parallel to the other plane. Now let us go through the question. Draw the projection of line AB of length 50 mm parallel to VP and inclined at 30 degrees to HP. That means here inclination with HP is given as 30 degrees and the line is assumed to be parallel to VP according to the question. And now let us continue the question. One of the endpoints of the line is 20 mm above HP and the line is 30 mm in front of VP. That means one of the endpoints, that means as we know that there are two endpoints on the line, among that one of the endpoints is at a distance of 20 mm above HP and entire line is 30 mm in front of VP. It is what given in the question. In such cases, what we have to do is whenever the line inclined to one plane and parallel to other plane is given, first of all we have to start from the fake view, assuming that line parallel to both the planes. I am directly drawing the projections because you need here the rough work. I can't represent in the rough work. As we know, as we are following the first angle projection, we know that HP and VP, positions of HP and VP. This is what the position of HP and VP. Now let us assume that, let us start from the fake view. Whenever line inclined to one plane and parallel to other plane is given, we have to start from the fake view, assuming that line parallel to both the planes. As we know that whenever the line is parallel to both the planes, true shape of the line can be seen from both front view and top view. Here let us assume that above and in front distance of the line is given as 20 and 30 mm. Let us assume that line is 20 mm above HP and 30 mm in front of VP, parallel to both the planes. Whenever line is assumed to be parallel to both the planes, you can see the true length of the line from both front view and also from the top view. In front view, as this is the fake view, let us represent these points as, keep this A dash as constant, and that is the position of the point B changes. That's why I am representing with the suffix 1, B1 dash, like this. This is A, this is B1. As this is fake view, we have to draw with thin lines. Now that means here this point, as you have considered that the line is 20 mm above HP and 30 mm in front of VP. Line is 20 mm above HP and 30 mm in front of VP. But according to the question, line is not parallel to both the planes. Line is parallel to only vertical plane but inclined to horizontal plane. That means, as we discussed just now, always horizontal plane inclination can be seen on which plane? Vertical plane. That means from which view? Front view. Here what is the inclination of horizontal plane is given according to the question? 30 degrees. That means line is given as 30 degrees inclined to HP. Always HP inclination can be seen from which view? front view. That means here in front view we have represented the line as A dash B dash. Now we have to tilt the same line A dash B dash up to angle 30 degrees, because we know that always horizontal plane inclinations can be seen on vertical plane, that is from front view. That means in the front view, in the front fake view A dash B1 dash, we have to tilt this line up to angle 30 degrees. That means with your compass A dash as center and with radius A dash B1 dash, just draw an arc with your compass. Just draw an arc with your compass with A dash as center and with radius A dash and B1 dash. And take your protractor and measure angle 30 degrees, whatever it is given in the question, and join to this arc, making angle 30 degrees. Making angle 30 degrees. Whatever the angle given in the question, you have to do. That means what we have done here in the first case, we have assumed that line is parallel to both the planes. Whenever we have assumed that line is parallel to both the planes, the true length of the line can be seen from both front view and top view. But according to the question, the line is not given parallel to both the planes. Line is inclined to one plane and parallel to the other plane. It is given in the question. In such cases, we have to start from the fake view, assuming line parallel to both the planes. And according to the question, 20 mm above is given and 30 mm in front is given. With that, I have drawn assuming line parallel to both the planes. And here, according to the question, here inclination with HP is given. As we know that always HP inclination can be seen from front view on vertical plane. On the vertical plane, in the fake view, we have represented A dash B1 dash. The same line A dash B1 dash is rotated with compass. That means with A dash as center and with radius A dash B1 dash, I have just rotated this. I have drawn an arc, and from A dash measuring 30 degrees with protractor, I have joined the line. That means just as it is not possible to tilt in drawing, just we have tilted with the help of compass. This point will be B dash. This is the original view or true view. Now if you project the same to the top view, this point will be, this line will be AB. This line will be AB. That means whenever the line inclined to HP and parallel to VP, true length and true inclination can be seen from front view, whereas in the top view you can see the reduced length. This is the true length. Which is given as 50 mm, and later on measuring with your scale, measuring this length AB, you have to give dimensioning. Measuring the length AB, you have to give the dimensioning. What is the reduced shape? What is the whatever you get. Here one thing should be kept in your mind: whenever the line inclined to one plane and parallel to the other plane, in one view you can see the true shape along with true inclination, whereas in the other view you can see the reduced shape. The reduced length should be measured and you have to dimension. Now let us see the one more question. Whenever the line inclined to VP and parallel to HP. Whenever the line inclined to VP and parallel to HP. Now let us go through the question. Draw the projections of the line AB of length 50 mm parallel to HP and inclined at 40 degrees to VP. Parallel to HP and inclined at 40 degrees to VP. You have to always, whenever you reading the question, you have to underline the important terms, inclinations and all those things. Here parallel to HP and inclined to VP is given. One of the endpoints of the line is 20 mm in front of VP and the line is 30 mm above HP. That means inclination of the line is given as 40 degrees with which plane? Vertical plane. With vertical plane. That means as we know that always vertical plane inclinations can be seen from top view. That means on which plane? Horizontal plane. And here above and in front distances are given as 30 and 20 mm. As it is clear that the line is inclined to VP and parallel to HP. Whenever line inclined to VP, inclined to one plane and parallel to the other plane is given, we have to start with the fake view, assuming line parallel to both the planes. In first angle projection, we know that VP and HP comes above and below the reference line, and here above 20 mm above and 30 mm in front, 30 mm above and 20 mm in front is given in the question. Therefore, at a height of 30 mm, this must be thin, that's why I am representing A dash B1 dash. This is A B1 because the point B's position keeps on changing. That's why I have represented with B1 fake, as this is a fake view. As the point A's position remains constant, it is represented with A and A dash. And it is given at a distance of 30 mm. As this is the rough figure for you, you have to measure and you have to draw correctly with scale. Above and in front distances. And in the first case, we have assumed that line parallel to both the planes. Therefore, true length of the line can be seen from both front view and top view. Now, let us tilt the line making angle 40 degrees with VP. We know that always vertical plane inclinations can be seen from which view? Top view. That means on which plane? Horizontal plane. That means on horizontal plane we have represented the line as A and B1. A and B1. That means the line A and B1, the projection A and B1 is to be tilted up to angle 40 degrees. For this, what you have to do is you have to take your compass with A as center and with radius AB1, draw an arc. With compass A as center and with radius AB1, draw an arc. And with your protractor, measure 40 degrees from here, from point A on the line AB1. Measure 40 degrees and and draw a line which is nothing but AB. If you project the same to the front view, you can see the reduced length A dash B dash. A dash B dash. That means here one thing is clear for you, that whenever the horizontal plane inclination is given, true length and true inclination can be seen from front view, and whereas in the top view you can see the reduced length, whereas whenever vertical plane inclination is given, the true length and true inclination can be seen from top view on HP and reduced length can be seen from front view on VP. It means on vertical plane. Now just give the dimension. Here, as we know that the length of the line is 50 mm, and here you got the reduced length which is represented as A dash B dash. By measuring its length, you have to, whatever you got, you have to give the dimensioning. You have to give the dimensioning by measuring the reduced length. Here the presentation of lines is very important. Always I keep on saying you that presentation is important, because in engineering drawing, just if you draw instead of thin line, if you draw a thick line, unnecessarily you will lose your marks. Just be focused, and it won't take much more time also, like first unit. Once you are good at imagination, you can draw any type of question related like this to these lines or points. I hope everyone is following and getting understood, and listen to this twice or thrice, so that at first time you may not receive this. If you listen to this concept, putting concentration twice or thrice, certainly you will get understand. Still, if you are having any doubts, you can WhatsApp me.